Yeah, I welcome you all to the Blockchain Developer Series session 4 on the XRP ledger. So today we have Ajit Kulkarni and Marco Neri with us. So welcome you both, and I would get started with the view of both the speakers. So Ajit is a senior product manager on the RippleX product team at Ripple. He works on building products that enable ledger to interoperate to the pharmaceutical supply chain for manufacturers and wholesalers. Prior to Chronicled, Ajit was at Cisco, where he started as a software engineer and moved to product management. So Ajit has an MBA from UC Berkeley, Haas School of Business, a MS in computer science from Virginia Tech, and a Bachelor in computer engineering from University of Mumbai, India. So welcome, Ajit. Then Marco Neri, he is a developer advocate at RippleX. He has more than 10 years of experience working in the payment industry as a developer and a project manager. He created Zaldo in 2013, one of the first apps using XRPL to move funds across the borders, serving migrant workers in the United States. He is interested in financial inclusion, venture capital, decentralized system, and digital assets. So over to you, Ajit and Marco. You can share your screen and start the presentation. Thank you.
Yeah, thank you, Manjiri. Thanks a lot. Hi, everyone. Thanks a lot for having us. It's a pleasure to be here with all of you. Yeah, so I'll be giving a brief introduction about the XRP ledger and what our team does, and then Marco will be our main our main expert who will be talking about the XRP ledger and its different functionality. So, so Ripple is a software company and based in San Francisco, and within Ripple we have the RippleX group, which basically our main goal is to enable the growth and adoption of the XRP ledger. The XRP ledger is a layer 1 blockchain solution, and it is the third blockchain that came into existence. The first being Bitcoin and second being Litecoin, and we have been running since 2012. The XRP ledger has been running since 2012, and now we are just trying to get more developers to work on it, and we are adding a bunch of exciting features to make it easy for developers to write applications, as well as enabling different NFT and DeFi type of use cases. And we'll go into more details about that. And yeah, we are very excited to be here. Ripple is one of the contributors to the XRP ledger, and yeah, we are looking forward to having a nice discussion. And yeah, I'll pass it on to Marco. Thank you.
Thank you, Ajit. Yeah, my name is Marco Neri, and I'm a developer advocate. I've been very involved in the payment space, especially in building solutions that utilize stable coins to facilitate cross-border payments. And yeah, I'm going to be talking about like how to interact with the XRP ledger, which is basically the underlying technology that powers XRP. XRP, obviously, it's a very well-known asset. It's been around for a long time, and it's kind of like it's been known for being one of the fastest assets, and that it's highly optimized for payments, and that's one of the reasons why it's been successful. A little bit of history. In 2009, that's when like the space was born. It was when the Bitcoin paper was released by this pseudonymous Satoshi Nakamoto. And actually, it's impressive that a few years later, in 2011, some developers that were super interested in Bitcoin were realizing that there were still some use cases that were going to be important, but it was not possible to do all of it with Bitcoin. So there was going to be room for other innovations in other ledgers. So back in 2012, that's what was when the first XRP transaction happened on the technology. The vision in the very beginning, and kind of like one of the things that was different from Bitcoin was, let's try to build on the same network, not only a cryptocurrency, but also other assets, other things that we see value in. It can be, you can think of gold or fiat currencies, but also like any asset that human beings see value in. Like, we, in a way, believe that they can all live in the same ledger, and that's kind of like the vision, how it all started. And then obviously 10 years later, it's clearly that the vision was right, and it's just a trend that continues growing. This is just to give a perspective why this is so important. Everything of value has been and will be tokenized in one way or another. So the kind of like the projection of how it looks, it's in the trillions of dollars. And this is like a lot of assets that will find its way into becoming digital assets on blockchains. So it's really important to understand the fundamentals of the technology and the use case that these things are designed and optimized for, and kind of the things that are possible. So I'm going to start by just, probably some of you are experts or know a lot about blockchain, but I don't want to make assumptions. So I'm going to quickly just go through a few concepts of history. So cryptography was already around back in those days, 2009. So it's been there for at least it was already there for 20 years. So I think in the 80s we already had like public key cryptography that powers like this ability to sign messages digitally. So kind of like replicate what we do with a check, like signing a message, so that other entity can identify who was the issuer of the message. So we have that technology, and we've had it for a long time. However, that was not enough to prevent like a double spend. A double spend means that I can, for example, write a digital check. Alice can write a digital check for $20 to Bob, but still the problem is, yeah, someone can receive that check. Imagine like a clearinghouse. It can receive a signed message with instruction of moving money, but still, Alice could do the same thing twice, right? So that's why you need a clearinghouse. So that's the problem that was highlighted by these technologies. So even though you could authenticate a message, you don't get rid of the central authority, which is exactly what this technology is intended to replace. So so what's needed? Well, I mean, Bitcoin solved this in a very unique like way, which is very clever. It's okay. Let's list all the transactions in the form of blocks, one transaction that happened after the other, And then we create a fingerprint of the whole block or list of transactions, and we include it in the next block. That creates a chain. And that's exactly what where the name is coming from. And what this creates is a data structure of, like, it's a canonical like record of all the transactions that have ever occurred, like on the ledger since the very beginning, since like there were no Bitcoins, basically. So that's in general a very powerful concept. And not only that, but this data is replicated in different servers, like in what we call nodes. So they all share the same state, and that's what's important about it. So it's not only in the control of a single entity or the systems of a single entity, and that's why we call the systems decentralized. So this technology obviously was revolutionary, but it works in a very particular way, and in a way it has some strengths, but it has some other potential problems which have to do a lot with payments. So as you all know, networks like Bitcoin can fork. And so, for example, the way that people realize that a transaction is final or that has happened, it's basically which is the canonical record of transactions that you need to trust. It's the longest chain ever. So you can think that there are always competing chains. There's one which is it's the longest, and that's basically what the blockchain is. However, for example, a mining pool can create these blocks, and then they can be like merged on the main branch a little bit later. That's called a reorganization of blocks. And when that happens, without going into too much detail in Bitcoin, is that you cannot always be sure that a transaction it's finalized. So that's what we call probabilistic finality of transactions. You are always sure to a certain degree that a transaction happened, but it's not 100%. So the concept of finality of transactions, it's different from the one that we have in payments, which is payment either happened or it didn't. So we in a way we see Bitcoin like having that problem, and that's why like some systems wait 1, 2, 3, 4, 5 confirmations, because what that does is like basically increasing the probability up to a point that it's good enough to make sure that it's not going to be reverted, because it's like too much cost to generate a competing chain that will replace that previous one. So that's why like that's when people consider those transactions finalized. XRPL works different because it solves two things. First of all, it's optimized for like a different type of finality. Like deterministic finality is a transaction happened or didn't happen, and then that it's included in the other in the next version of the ledger. And also, instead of, as I mentioned, this ledger was thinking about multiple assets. So instead of like the way that Bitcoin works, which is using just a trace of transactions that use Bitcoin, like in a way, this is a different model. In the Bitcoin model, probably you're familiar with, it's unspent transactions, which is like, so we don't have the notion or the concept of accounts. On XRPL, it's the first blockchain that utilizes this concept of creating accounts, and those accounts can hold like multiple assets. But you can think of this more as the way a bank works, which is like storing a piece of information that it's your balance. So those balances will change depending on the transactions that happen during a period of time. And when consensus happen every 3 to 5 seconds on XRPL, and then a new version of the whole ledger with all the transactions will include those changes. So that's how you still have the same thing. You still have a data structure with a link of every single transaction in history, and you also have that data shared in a decentralized fashion. So one person doesn't have to rely on a single authority, which is the same problem here. You have this blockchain in the middle that you can access from anywhere, and everyone can use as a canonical source of truth. So that solves kind of like the same need that we initially had. And again, so you can think when an abstraction of the XRP ledger as a ledger where there are accounts, and those accounts will move through transfers, different assets, but not only like the native asset, which is XRP, but also other assets that other people's other entities can issue on the ledger. So kind of the functionalities that the ledger has, it's not different from other blockchains, except that the way that they're implemented, they may be a little bit different. So for example, if you think of a ledger, you also now think about, okay, tokens. So fungible tokens, as I said, if you want to mint gold coins on a blockchain, that's possible. In the case of other chains, you would have to use smart contracts, and there are like standards that people use in order to use the same functionalities, the same methods. For example, for fungible tokens, it's well known on something like Ethereum ERC20 tokens. That's basically a smart contract that has different functions, like the function to mint, the function to transfer, and those things. But you build your smart contract and then you deploy it into the blockchain. So here the difference is you can do the same thing, but the feature is built in, so you don't have to write your smart contract. That in a way can be a little bit restrictive, but it's actually used. I mean, the way that we see it is more like it's a more secure approach to having functionalities in the ledger to prevent exploits and to prevent all sort of problems that we've seen that can happen on especially non-standardized smart contract functionalities. So you reduce the surface of attack by having like less things that you can do as a developer on that ledger, but still you have the functionality that allows you to mint a fungible token. And in the same fashion, we also have a built-in functionality to exchange any asset for any other asset in a decentralized way. XRPL implemented the first decentralized exchange. So you have an order book where you can put any bid or ask to exchange any asset for any other asset, and you will also have a functionality to find what is like the best path. So for example, if I put an offer to exchange my Mexican pesos for XRP, and in another part of the world, someone else is doing the same thing, but with euros, I can actually go from pesos to euros using XRP as a bridged currency. And that's what that is called pathfinding. So that functionality is as well built in the decentralized exchange. And in the same way, the NFTs will be a native functionality of the ledger that will allow you to mint burn and create offers to basically swap or sell those NFTs. And that's in general an overview how functionalities are embedded in the same blockchain. And I can tell you more about like how new features come into the ledger, but in a way, like there's an upgrade, like an upgrade system. I mean, we think of upgradability as someone can come and build a functionality using C++, and they propose the amendment, and all the validators will vote. And if the vote passes, that means that there's a supermajority accepting the change. So a new built-in functionality will be added to the ledger. Okay, so now I'm going to talk about how to interact with the ledger. And please, I'm going to stop a little bit just to ask if there are any questions about any of the concepts that I mentioned, or if there's anything that was not clear. I'm happy to stop here, because those are like just the basics of blockchains. So feel free to ask any question. And if not, I am going to continue talking about the interaction with the XRP ledger. So as in any other blockchain, kind of the technology piece that it's there, it's it uses keys, right? So this is basically an account, but an account it's a map to a public and private key, which is just again a way that uses cryptography to sign digitally messages that you will send to the ledger. So the secret key, it's basically the one that you use to derive the public key, and basically the public key becomes your identifier in the network. So anyone, you can share it with anyone, because that's how they will like send you a token. And the secret key, it's obviously the string of bits that you will use to write transactions to the ledger. So it's something that obviously no one else can know except yourself, because anyone knowing this string of bits will be able to have access to your funds, because they can send a transactions on the behalf of this account. So that's the simple and kind of like the goal of this is to interact with any of the entry points of the ledger. You will have to send a message with the instructions about what you want to do, what type of state changes in the blockchains do you want to perform. And then obviously depending on if you have the permissions based on, for example, the number of assets that you have, this like the one of the basically the nodes will use a consensus mechanism to compare nodes, and there will be, through voting, a way to all agree on valid transactions. And that's kind of like the idea behind sending messages to the blockchain. Again, just the only thing that the signing of the message will do is to be able to help the validator to verify the integrity and the authenticity. It's like if I instruct the transfer 20 XRP, so basically no one can alter those like 20 XRP. That's what integrity means, and authenticity, that it's obviously coming from the owner of such account. This is how an instruction message, for example, to the XRP ledger looks like. So obviously, depending on the transaction, you will have a transaction type. So for example, if you want to do an XRP payment, you will use this payment. That's one of the many transaction types that it's supported by the XRP ledger. And you can think of other cases, like if you want to exchange your asset, basically you can change this for create offer. And that's another transaction type that it's supported by the XRPL. It will also obviously send, put your account, like the account that the payment it's being sent from. You will also include the amount expressed in drops, not in XRP. Drops, it's the smallest unit on the XRP, like that represents XRP. So for example, in the same way that Ether has Wei or Bitcoin has Satoshi, like those are like the smallest unit. On the XRPL, so we have drops, and basically one XRP, it's the same as 1 million drops. So here, for example, that means that we're trying to send 20 XRP, so that's 20 million drops, and we will like put which account we want to send the money to. We will also need other parameters that these have to do a lot with. So all the transactions, like they include a sequence number, and that's used for security. So for example, if you want to send messages specifying which transactions should happen before which other transactions, you can use like a sequence number. So in order to do that, you need to know which transactions have already happened using an account. So what I will tell you is that these other parameters, like including the fee or the sequence, those are things that you can ask to the ledger about. So you don't have to know all of these things. That's why like we have a helper function that will go to the ledger, ask, okay, give me an estimate of the current fees on the ledger to add a new transaction. I will explain a little bit more of that, but you also can do the same thing with the sequence. So because you will say, okay, I wanna do this transaction, but I still need to know which like these other parameters that are needed. Instead of like you building them, you basically have a helper function that will help you populate this. I'll explain more in detail in the example, walking through the code. And again, this is just an abstraction, but it's mostly how the systems are not living in the same infrastructure necessarily. So normally you have the blockchain, you have an app, and also you have a third system, which is where like your keys live. So normally, for example, this can be a wallet. On the XRPL, there is an ecosystem member that has developed a very well-known wallet, that it's a mobile wallet, that it's called XUMM, XUMM. And basically, this is just a client. It's software that lives on your mobile device, and it will store your keys, so that the system that creates a message and that creates the transactions to be sent to the ledger, they don't have to touch the secret account, because in the case of an attack and hack, that information would be compromised, and that's why you want to create a separation there. And so this is more or less like the architecture of how a blockchain application, especially on XRPL, looks like. So you can think of this as a web app that will form and create the transaction message that it's intended to be sent here. It will be sent to the wallet, which will sign the message, and once that it's signed, then it can be sent to the the RippleD server, which will be like the door to create any changes in the state. And that's it. That's how in general the thing works. It's very simple, and basically right now the way that you can talk to the network to the XRPL, it's through WebSockets. So you can use any system to open a WebSocket that will allow you to send bidirectional messages, and you will like send the instruction, and you will get a response. That's a very clever way to interact with the ledger, and that's basically it. So I'm gonna walk you through the documentation, how you can like do more than just a simple message. But first, I want to thank you for the time, and also I want to like share with you the link to our Discord server, where we normally hang out, different developers. So if you have questions, for example, regarding an application that you're building, so a good way to go, it's xrpldevs.com, and that will take you to the Discord server. We have different channels for different technology pieces that are being built, and the different new functionalities that are being tested, and also, for example, a channel for the discussions regarding NFTs and stuff like that. With that, I'm gonna also make a stop and ask if there's any question. And if not, I'm gonna show you how basically the documentation is. So you can see xrpl.org as, again, all the documentation. This is a place where if you have any intent to build in the ledger, this is the kind of like the Bible. So it has concepts depending on, for example, the language that you use. So if you're a JavaScript developer, you can go directly to JavaScript, and here you will also like find different shortcuts to uses of the ledger, how to send a transaction and things like that. You can also directly go to the popular pages. For example, XRP, sending XRP is one of the basic things. So here it will explain you, I mean, what do you need? If you need like a library that you can use with JavaScript or with Python or Java, here are the links. And here's also a way to test a little bit the flow. So I'm going to walk you through the flow of sending an XRP transaction by using this. So as I told you, you will need, first of all, like a key pair, your public and private keys. So what this thing just did is to create the public and private key, which that is not, it's not an operation that has to do anything with the ledger. Basically, those are, you can use you know, kind of like the same way as Bitcoin. It uses the elliptic curve cryptography to generate the keys. There's more information on how go from a private key to this account and secret, but basically it's the same principle. So you will run a function, have these ones, and then by receiving XRP, that's a way to activate the account. So you can think of XRP as the fuel that it's needed. So for example, if you need to do any change to the ledger, including like this sending XRP, you will have to pay a fee. Normally it's negligible, but it's still a fee, and it's denominated in XRP. So that's kind of like the utility of XRP. It will always be the currency that you can pay fees with. So now that you have, so here it uses a faucet that the faucet will put 1,000 XRP on this account, and that basically will make that the account has enough fuel to create transactions. The next thing, it's basically connect to the WebSocket. We have a DevNet, a testnet, and basically this is all asynchronous code. So in a way, like the first thing that you need to do is to connect through the WebSocket. So basically that only shows what these lines of code will do, which basically will create a connection to the network. And now that we have the connection established, the next thing is again to send the payment, which again it's the same thing that I show you in the presentation, but maybe slightly different because it uses different accounts. And it will show you what to do. I also mentioned that you will basically prepare the transaction using a helper function. So what you will do, it's there's this method called autofill. It will do for you basically get the other information that is needed besides these 4 things that have to do with the conditions of the ledger, and it will prepare the message for you. For example, here, what it did, basically it autofilled the another a sequence, and the fee. This fee can go up depending on the usage of the ledger. Basically, if there's congestion and too many people are using the ledger, so the way that it works is that the fee is dynamic, it'll go up. But here now you have a complete message that can be signed with all the parameters that are going to be expected. And the next thing will be just to be signed, right? So again, you can see the different examples, but basically with JavaScript, you will now the prepare message use the sign method. And basically this will print just the hash and the sign blob, which just shows you the way that it looks. And in a way, as I told you, we need to send still the sign message to the ledger, so it can be basically the merged to the state of the network. So this is basically what the last step does. You submit the transaction and you will get a response. In this case, was successful, and basically that's it. And you can then check on the ledger if the transaction happened or not. And there are multiple APIs that you can use to check the status or to check the accounts to see if the transaction happened correctly. And that's it, right? So you can, for example, again, check the status if it succeeded or not. What accounts were altered, were impacted by the changes in the transaction, and that's basically the principle. So that's the very basic. Obviously, you can do more than sending XRP, which it can be creating your own token or representing like a fiat currency using tokens, what a stable coin would be. But in general, all respond to the same principle. So I have a question here. I want to understand more on how consensus is reached in XRP. So use proof of work or proof of stake. So I like to understand how decentralization. Okay. Yeah. Okay. So yeah, again, it's true. The consensus mechanism, it's not proof of stake, neither it's proof of work. So in a way, what it's called federated Byzantine agreement, it's the consensus mechanism that it's used by XRP ledger. You can think of this. I mean, you can obviously. So the way that the Bitcoin works is that it delegates to miners the creation of blocks, and they will like just put, let's say, at stake, like the energy spent to create a block, and then the other. So basically, the network will verify the block and will accept it or reject it, but that has to do with, so you have a mechanism for which only a few miners can randomly create new blocks or add pages to the ledger book. Here it's a little bit different. So an easy way to explain it, it's that it's rounds of voting. So you send a message to the ledger, and what happens next, it's that it will be validated, and there will be communication among the different validators, which are the nodes in the network, and they will like compare nodes and say, hey, I'm proposing this changes of the transactions that I'm processing, and then the other ones will vote on the validity of those transactions. And once that there's a majority, it's basically there will be a new state that will be replicated to the entire network. So you can still, let's say that it's not because it's malicious, but let's say that you still have like 20% of the nodes that went offline. So you still have the ability for the network to be fault tolerant, to resist some nodes going offline by having, you don't need 100% of the nodes to vote on the ledger, and yeah, you can think of there are always risks of malicious actors to take over the network, but there are multiple ways that behavior is mitigated. So in this way, you can think of every node on the XRP ledger as having reputation, right? So it's not entirely anonymous as in the case of Bitcoin. So it's not industrial. Here it's like a network of servers that will run this RippleD software, and basically each one, it's run by a reputable institution. So it's not that an anonymous person is voting or anything like that. So there's a lot of things at stake in a mechanism like this. But you can think of like you have different institutions that will create a federation, but still no single institution is in control. That's why it's not centralized. So centralization is not like a binary thing. It's not like 1 or 0. Here it's more about it's decentralized because you don't rely on a single institution to process those transactions, but you still form the decentralized network and through like this through this consensus that it uses voting every 3 to 5 seconds to agree on a new version of the ledger. I don't know if that answers the question. It was a long response, but that's
Yeah, we have another question
okay.
in the chat. So do we use Solidity as a language here?
Yeah, so no, we don't have a language to write smart contracts. The reason being that, for example, as I said, if you want to add a new functionality to the ledger, well, what you will have to do is basically write software that will modify the software that it's run by the nodes, so that functionality is now part of the things that the nodes will validate. It's not, so no one it's not like I will go and write a smart contract and I will deploy it to a blockchain. Here's different. So here, if you want to have a different feature, you will have to modify the code of the ledger itself. So for example, people are proposing different functionalities that in a way are similar to what a smart contract would do, but instead of that, they will like write code in C++ and that will basically be proposed, and the other validators will have to vote on the acceptance of the new functionality, which is obviously very slow and very different from what it's achieved with smart contracts. But that's the way it works. So we don't have a smart contracts language, and it's not the way that it was architected.
Yeah, Marco, I have a question from my side too. So can you tell us more use cases about it, giving us some examples? And the second is, if suppose I know Ethereum, I worked on it, and there are some other blockchains people are having understanding of. So how does one can start learning XRP ledger? So like you already told us through the link, getting started and everything, but if somebody want to like decide, okay, JavaScript, Python, or which other language to choose, so what you recommend from your side? Maybe that would
yeah. No, it's a good question, and just to link this one with the previous one, like there's a lot to build, right? So kind of like the different approaches that people think that by building smart contracts is like what solves all, and it's almost like not the case. If you see other blockchains, like a lot of projects are using the same contracts and recycling the same code because of like they want security. So it's like it's not safe to build new smart contracts. So it's better to use the things that are tested already. So here's the same approach. So things that are tested, they get merged to the code and then people use them. So for example, if you still want to build a use case, one can be like governance mechanism using a voting token. So let's say that you want to build a DAO and you need a token. So you can do that on XRPL. Basically, you will issue a token, and then there will be a few steps to basically cap the supply, to basically like make sure that no more of that token can be created. So that's something that can be done on XRPL. That's it. But the use case will be that you can implement your DAO basically by creating a token. Everyone will know, because of the assurances that the ledger provides, that no one will be in control of the token, and you can use the token to vote by basically embedding the signal of the votes, for example, in the ledger using transactions. So you can use a ledger just as an anchor where you are sending transactions, and those transactions get embedded in the memo field, which is basically well, in XRPL, it's called destination tag, but basically there is a way for you to put more information on a transaction when you send the message to the ledger. So and again, a big part and a big portion of Web3 applications also is building software that doesn't necessarily use the smart contract itself, but all the use cases that will facilitate the usage and the understanding of the system. Basically, the interface, the web app, the mobile app, everything. You can build your Java application. You can build your JavaScript. You can use React. You can use whatever framework it's best for your interface, and basically that's the important part. Now, blockchains, in a way, there's a discussion, and it's more like a philosophical discussion. How much do you store there? Because in a way, these systems are, even an XRPL, which is fast, 3 to 5 seconds, is slow compared to other systems like a traditional payment network that it's way below one second. So in general, what I see is like there is not a lot of things that you can do on the ledger just to make sure that you are getting value from using the blockchain, but not necessarily putting all your logic up there. So I just want to make sure that it's clear that you can still build a robust application, that it's a web normal application, and you can use the ledger just as a source of truth that will facilitate the creation of trust among the different participants of the organization. So you can build, obviously, that I mentioned a DAO, but you can also, I don't know, build a stable coin and facilitate payments in your country. That's one of the main use cases that people thought about when they started conceptualizing XRPL. And yeah, all the world. So right now, the functionality of NFTs has been proposed, and it's in the process to be voted. And depending on that, will be either merged or rejected, and that basically will create the ability for anyone to just mint NFTs with the same, like, sending just a message, like the way I did it on the example. And that is super helpful for anyone, because you can build a marketplace, and you don't have to build all your offer system, because you can use the built-in functionalities of offering NFTs and selling, minting, and things like that. So the possibilities are huge. If you are an artist, you can put your collection the same way that you put it in other chains. So it's those are the things that are come to my mind as an example.
Yeah, quite a good insight. And can you also, like, in one line say like which programming language to start with, or like what exactly is the starting point for newbies? Maybe with the link, or maybe you can share your screen again and just give us the point.
Yeah, so I will say two things. I mean, right now, XRPL.org is where, like, we have a few tutorials. We're trying to simplify that. So in a way, like, in the coming couple of months, we are making a learning platform that will explain in further detail. But right now, it will use a lot of the information that it's there already. Sometimes it can be dense because there's a lot of information, but for now, it's still a good place to start. Also, like, as new questions come, I think that it's important to start meeting with other developers in a more social way. That's why I recommend Discord, because, for example, we have a channel there for JavaScript developers. So if you have a question that has to do with I don't know, some behavior that you realized when using, like, the XRPL.js client. So yeah, that's a good point where all the answers of the people who know and to use the JavaScript client, I think they can be helpful. But right now, those are the two resources that I would suggest people to check.
Okay, yeah. Would you be able to send the link of Discord in the channel, maybe, so people can join it?
Of course.
Yeah, thank you. Yeah, I don't see any other questions right now. So thank you so much for the wonderful and insightful session, Ajit and Marco. So I really hope the audience got quite a gist into how the XRP ledger works. And I would like to thank everyone for joining today's session, and note that the recording will be available in few weeks, and we will add the link into the Slack. So
Sure.
yeah.
If there's also any other question, I put my email.
Yeah,
wait,
sure.
I think,
yeah.
Oh yeah, maybe I just put it to panelists. Probably, let me.
Yeah, can you
Sorry.
copy in there, everyone? Yeah. Yes, we have it now. So yeah, thank you everyone, and I wish you all a pleasant evening. Thank you.
Thank
Bye.
you. Bye.
You.
Bye.